multi-shaders programming in Open means what we have seen by now. I have one program, and inside that I enable depth testing and we clear the buffer and so many things. That is kind of a state management. And then followed by I start drawing I compile the shader and then use the shader and whatever the vertex attribute like vertex coordinates and its normal and texture and then texture unit, lighting whatsoever. Then I just enable everything and I start drawing. So now I have in my scene, I have one more. Okay, like if I am drawing a kind of a car, then car is one, and then car will glow like this and this and that. Okay, what about car has two lights? Car has wheels. Anyway, car had wheels, but the wheel would rotate little differently than car moves, the way we see. And light would behave differently, like light would glow, irrespective of car is glowing or not glowing. Now, car is moving, and then there is a road, there are trees. Okay, so now if I bring everything in one model, if car rotates, then tree will also rotate, and so it's not possible. Having one shader, generally a program has one shader, vertex and fragment shader. Typically we never think that it is only for one object. Okay, and what about if I want to draw multiple objects? Multiple object in the sense, like anyway, I had a car and it has a wheel and it has a lighting and everything. Multiple object in the sense that all object will have different characteristics. Okay, they will move independently and they will light independently. They will texture up independently. They will rotate independently. They will react to light independently. Like typical scenery, like a man is kind of just strolling on a grass or kind of in a park. So park trees are different, man is different. If there are fountains, then they are different. So all are different. That means this is the real world. So multi-shaders in the sense that how we can go for, if I go for multiple model, for each model, now I need to have multiple shaders. So how multiple shader comes into the picture? When we, in shaders programming, when we go for doing, like if I don't have shader programming, if I go for fixed pipelining, then it is pretty easy. Means different models are there. And when one model is drawing, just push the matrix and pop the matrix. And when you push the matrix, transform your coordinate and draw yourself and just come out. And then push the matrix. So this way, model by model, we draw in the fixed function pipeline. But that is not the same in shaders programming. So in shaders programming, a multiple object, if we want, then we have to go for multiple shaders. Each shader is for one object. So that is multiple shaders. But then how, means if I have a like vertex shader, then what we decide in the vertex shader? We decide mainly the new position, new transform positions in vertex shader. And for each vertex we define the color, if not then in fragment shader, per pixel wise we define the color. Okay, so that is kind of the actual need of a vertex shader and fragment shader. Now, if I have multiple objects with multiple fragments, then everywhere position would change and everywhere coloring would change. So how we achieve it? Like when I do positioning, when I do the stuff, then I call GLUs program, and whatever my shader is, that will come into effect. And after that, whatever I do, like binding to a VAO, and then what transformation I do, so everything will go in that shader that is currently in use. At one time we use one shader, but still how everything goes in one kind of buffer that we see on the monitor. When shaders are different, all parameters are different. So if I see the frame buffer means whatever we see on the screen, that is the color buffer. Okay, but along with color buffer, other buffers are important, like depth buffer, stencil buffer, whatever work we do. And like if I go for any transformation and coloring and lighting and so many things, then we change the color buffer. But depth buffer will have, if I enable the depth buffer will have entries for each perimeter. And then depth test will arrive after fragmentation, and it will start culling whatever is hidden. So, if we talk about depth buffer, so everything goes in color buffer. But whatever the importance of the depth buffer is, like this is front and this is back. Okay. Now, first I am drawing the front, then I am drawing the back. But in actual picture, it will draw up before the front. Means whatever is drawn at the end, that will appear in the front. Means that is the actual drawing. But if it enable the depth testing, so everyone's depth is it is registered, and at the end of depth test, they will, even though I draw back side at the end, but it will go away because that is in the back side. So that is depth testing. So in OpenGL, everything depends upon the frame buffer. Frame buffer is nothing but it's a data structure that keep pointer to color buffer, depth buffer, and stencil buffer. So application wise, we maintain same frame buffer. And now, if I am drawing with one shader program, it is going to same frame buffer. I am drawing with second shader program, it is going to second frame buffer. It is going to same frame buffer. So frame buffer is same. So when I use one shader, there I do GL position transform. It will go at that location, and then it will make the drawing using fragment shader, vertex shader, and fragment shader. Now, if we use next shader, then it will go ahead and it will do drawing, and so means all shader would finish drawing through same color buffer and same frame buffer, same depth buffer. So that is same. Okay. Now after depth testing, depending upon their depth, so they will be culled. So we will achieve the whatever we want. So multiple objects. So now if I have a car, then I can afford car is different. Wheels are different. Light is different. Okay. Many parts can be different. They can be assembled together. And then wheel will have different different shader. Car will have different shader. Light will have different shader. They may behave differently if I move a car, rotate a car, or something like that. So that we'll see then. It is car is running on a road. The road behave differently. Then trees are there. Tree will behave differently. So for them we will have a separate shaders, and then every shader would get chance to execute. And so this promotes the idea of you can say like aggregation, okay, or loosely in aggregation or composition, okay. So like a car can compose a wheel, or in aggregation a wheel we can provide from outside, but car contains a wheel, so transformation and those things will propagate through. So good designing comes into the picture. Now I can have a ready-made car model, where from outside, like it comes under design pattern called flyweight design pattern, where we have intrinsic and extrinsic. And from extrinsic, we can kind of push a new wheel and new light, and then it can start behaving. So I can just create many models and keep in a library, and ready-made I can use whenever we want. So multi-shaders or multi-model, how we draw and how we can use efficiently, because like if I talk about electronics, then power of electronics is its speed. Okay, there is nothing special about electronics, but the way it has changed the things because of its speed. Like that, if we have a GPU, it has speed of calculation. So, if speed comes, then means design to everything changes. So, we cannot live in the same world. So, things would change. Now, we have GPU, and now we have fast moving objects. So, we cannot go for fixed function pipeline. So, how we will manage GPU against various models and multiple shaders, their transformations, and then their material use, and then their lighting, and so many things. This much complexity, how we can make life easy. We'll continue on desktop. This is Linux Mint. Okay, so briefly, this multi-shader is developed in kind of various phases. So whatever we can show. Okay, so a frame buffer is a data structure, and this data structure keeps color depth and stencil buffers. Color buffer, depth buffer, and stencil buffers. Okay, so color buffer can be filled with various shapes, and shape buffer has an optional entry. So shape has an optional entry into the various depth buffers. Okay, so shapes has entry into okay, so color buffer can be filled with various shapes, and shapes has an optional entry into depth buffer. So depth buffer can exist or it may not exist, and we have talked about the analogy of the depth buffer. If depth buffer is not enabled, whatever we draw, so that will come at the front. So that is problem with the depth buffer. So like if someone is drawing and he is drawing a circle, okay, and then he is drawing a rectangle, but rectangle coordinates are behind. Okay, so but if depth buffer is not enabled, rectangle would come like this. It doesn't know what is the depth of this rectangle. Okay, so that is so those information it keeps. So even though we draw the rectangle after we draw the circle, ellipse, but since it has more depth, so it will go kind of behind the scene. So this would be the kind of actual drawing, even though I draw a rectangle after the circle, but since a rectangle has more depth, so finally it will come as this. So depth buffer has importance, but it is optional. We can set, we cannot set. And why we don't set? So that has kind of importance. And many places we don't need depth buffer, like transparent. If we are drawing transparent shapes, then we don't need a depth buffer. Okay. So whatever is drawn after, so that we need to come at the front. Unnecessary computation in the depth buffer. Okay, so multi-shader programming fills some color buffer, same color buffer and depth buffer through various shaders. Okay, so this is a panoramic view. So frame buffer keeps a color buffer, depth buffer. Mainly it keeps a stencil buffer also. Now there are many shaders. One shader keeps many VAO. This shader also keeps its own VAO. I would rather say it's a composition rather than aggregation. Okay, so this is kind of composition. This is also a composition. Okay, now these are kind of attributes typically, and shader also keeps pointer to uniform variable, and they are generally projection matrix and model view matrices. So each have their own pointers. So when this shader gets chance, so this typically happens with GLUse program. So there is an API that hooks kind of, someone can just call like okay, so GLUse program and passing the ID of the shader. If that is called, then that particular shader comes into the effect and that writes on the color buffer. Okay, so each shader gets chance one by one to write on the color buffer. So it is same shader is writing on the color buffer, but if you use GLUse program for different shaders, then different shader one by one they get to write on color buffer and depth buffer. And since they manage different VAO, different uniform variable, different vertex shader, different fragment shader, complete settings are different. Only common thing is at the end they dump their coloring here. Okay, so anyone can dump their coloring depending on the kind of coordinates. So since color buffer and depth buffer is same, so it can be considered as kind of they share the screen. If this is the window, okay, so indirectly, not directly, indirectly, it would be considered as they are kind of sharing the screen, same screen, indirectly, not directly. Okay, because this screen is directly coupled to color buffer. Okay, so probably this is clear. Okay, so we will write. We have a ready-made code. Probably we can demonstrate it later. A shader, and which manages between VAO and so many things. So we will use that, and then we will kind of draw various shapes. Okay, so in lab session we will have like this. So what is multi-shaders? These wheels, can we see? These wheels are different shapes. It is attached differently, and this is a whole car. Okay, later we'll bring the lights also. Right now it is just white, but the light is not there. And wheel has its own movement, car has its own movement. They are attached to each other through various shaders. And then they will move together and they will show their characteristics. So that is the idea. So we can start. Okay, so we'll create a directory called GLSL multi-shader. It's empty, and we will copy the skeleton code. So that much probably will not write. So copy GLSL. So skeleton code, like it begins with, I can say like FGL multi-shader.py, and it starts with from OpenGL.gl import everything, from OpenGL.glu import everything, from OpenGL.glut import everything. So it's like that. Then we'll have depth init, depth display, okay, depth reshape, and then initialization code. Okay, so we'll copy those things. Okay, so that is the idea. So probably we'll copy from whatever we have developed last time. So we'll copy it. Okay. Now we have only one file. Okay, so we will edit this template. Okay, so probably these we'll edit. So this much we don't need. So we'll have init, and then we'll have shade model smooth, enable display, translate to kind of 15, it's okay. Okay, so done. And then we'll have kind of swipe buffer, and then we'll have a GLU perspective. Kind of angle would be some 30 and to 30, or since this is a car, we'll make it 50, 15, and model view. Okay, we'll leave keyboard like this. Okay, we'll change it or we'll remove it altogether, not required. We'll remove it altogether. Okay, so we'll write. Okay, so pretty simple, there is nothing, just to avoid writing, typing. So init has clear color, shade model, and we enable depth test. So post a kind of rasterization, we have fragmentation. Fragment color would be come into the picture, and then means fragment shader. After that, post that, depth test will be performed. Now we have depth buffer width, and we have set glut swipe buffer, and viewports we have set, and projection. For all this you can refer other tutorial that is in fixed function pipeline, and then projection identity, and then load identity, and here we have used double and 500 and done. Okay, so we will fill it. Okay, so in it will fill. So here we'll have kind of from shader. So as we told, we have a shader class that does shader, means it is a local local class. It is not global class. Okay, and then we'll have kind of shader I equal to none, and I would say global shader I. So we are free to do on shader I. So shader I equal to shader, and it requires ops file. So every shader has a ops file. So I would say there is no ops file. This is the top class shader file. Okay, it will contain many things like loco2. Loco2 is nothing but the car or the locomotive that we are showing here. This is loco. So loco, and then we have wheel. Okay, so these are the file we'll copy. Wheel2 equal to wheel. Okay, now we'll do kind of shader I dot add. So this is a top level shader. In that we'll add object as loco2, and we'll fill fix transformation as 90. Will tell what it is. Okay, so fixed transformation is like whatever we generate through Blender. So it comes as a kind of a pre-made, factory-made orientations. So we kind of change it in a kind of certain orientation we give as a fixed. So this much will happen always. Loco2 dot add object is equal to wheel.mtl. Object equal to wheel. So wheel object. So wheel2 would contain in the constructor. Okay. Fixed transformation. It has a big fixed transformation. Minus 2.4 minus 0.1 1.25. Okay, this is kind of a translation. There is a scaling also. 0.1, 0.1, 0.1. So this big is. And then there is a fixed rotation, that is 90, 1, 0 and 0. Okay, so this is how it is. Okay, slowly everything will be clear. So there is nothing kind of highly hidden here. Now we'll add loco2.add. So we have added wheel 2 with fixed transformation minus 2.4 minus 0.1 and 1.25 and S 0.1, 0.1, 0.1, 90, 100. Okay, so I'm not going to type it. So we'll just copy paste 4 times. So loco has 4 wheels. Object is same wheel. We are not going to create different objects. Otherwise it will eat our GPU badly. So I am not that rich. Okay, so it is look. Can we see why I am changing this? So these are 4 wheels and they are getting attached at different location in the car. So that's what I am doing, fixed transformation. So there where they will get attached. And then 1.25S and 990. Okay, so everything is same. and this meter would change. So minus 2.4, 0.1. So this will go in rear. I think it's clear. Okay, this is front one, and this would go in rear. Okay, so we are done. We can push other characteristics. So probably we'll do it later. So this much is okay. Okay, we'll jump to display, and after doing this, so we'll say shader I dot display key equal to whatever key is pressed, and pop matrix. Okay, so we will fill much needed keyboard function. So I think it is become keyboard func, and it will become keyboard, and here we'll add def keyboard and key and other parameters we get through this. Global is count and key press. So we'll add count and key press as global. So I will say count is 0, and where key press is none, nothing. Okay, so if key equal to, okay, we make sure that key is byte because all processings are happening in byte. Now if key equal to tab, then we are switching the, okay, so count equal to count plus 1% len shader I children. So it has children as various cars. For I in range len shader I children, shader I dot children, whatever is. Okay, I believe we don't need this. Okay, so time being we can just omit this. Okay, it is not that difficult. So util I dot keyboard key dot shader I dot children count transformation. Okay, so I believe we can just leave it like this. Key press equal to bytes of the key. So anyway, it's okay. So it will be key clut post re display. Okay, we'll not leave it, we'll add it. If key equal to, if we want verbose print, then we can say like okay, so print f whatever is I and shader I children I transformation equal to. Okay, so for I in range len shader I children. Okay, so I believe it's nice. Okay, so whatever shader right children we have for that transformation, typically we can print other attributes. Okay, so what is pending is we have to initialize the. Okay, so there are many things like what is util C. So shader already has util I. Okay. So I can say util I equal to shader util I. So we get the util I, otherwise we have done everything. Okay, so we have imported, now we'll copy those files. Copy shader.py here, wheel.py here, loco.py here, car2.obj, car2.material file, wheel.obj, material. Will copy some color file also, like red.png and blue.png, green.png, yellow.png. Okay, so now we carry these many files. What is required? So I believe I can try executing it. Oh, it came. Okay, so car has arrived, just new car. Okay, but it is not rotating. Okay, so we have to pass key and then children transformation. We have done this many times. So whatever shader right children count is, that count we have to pass. We'll try again. If it really rotates, it rotates. Okay, but wheels are not aligned. This is what I can see. Okay, so wheel coordinate need to be verified. Okay, fixed transformation minus 2.4. So if it is not, then probably angle is not correct. So it will be other way. Okay, I believe it is done. We can bring the car near. Okay, and if we can see the wheel is rotating. Okay, it's not that we have placed something that is fixed. So wheel is rotating. If I bring it back, wheel is rotating. It is really a car. Okay, it is really a car. Okay, what we can feel now. So this is not a kind of some enigma that we are typing in. So shader is a program that kind of it manages various shaders, and loco are derived from shader, wheel is derived from shader. So everyone maintains kind of vertex shader and fragment shader, and then we have a guy called shader I, and shader I is a kind of container shader and which has no object file, and this loco and wheel, if I see their constructors, okay, so in the we can put all this addition of the wheel in the constructor itself, but for demonstration I have put, so it should be kind of more containment. So in the constructor we have calling car.obj and wheel, we are calling constructor wheel.object, and it is handling few events. So that is this is local code, means this is not we have imported from anywhere else. And if we see this, whatever we have written, so in the def display, we call the top level shader display, and internally recursively it calls car, and then car contains wheels. So okay, so first also, so the top level containment we create, then we add the loco to the top level containment, and loco to loco we add all the wheel. How wheel would be placed? So one example I can show. Like I can just disable it. Okay, probably I can disable it. One example I can show where I want to put a fixed transformation. Okay, so I can just say it's enough. Just add a wheel. Okay, what it would do? This is wheel, this big. Okay, this is initial we have received from the blender. This is car and wheel are together. So this is the actual wheel that we have received. Now we are, okay, so this is actual wheel. Car and together. Okay. So this is the wheel. Now what we are doing is, to the wheel, we are adding the wheel and we are doing transformation like it. We are doing translating to some location. We are scaling to 0.1, 10 times down, and then we are rotating to in a way that would fit as a wheel. Okay. Can we see? It is fitting as a wheel, a real wheel at that occasion. So we scaled, we translated, we rotated, and it is really a wheel. And other wheel we have not placed. So if I remove this addition also, then there won't be any wheel. Okay, so probably that's okay. Now we can add other attribute also, like what would be its color and those things. I can say other attribute is OpenGL and material dot diffuse. Everything kind of can be referred in the texture and lighting shaders tutorial. Okay, so material dot diffuse is green, or I can place it red, no one can stop. Okay, now, so this is a hash, dictionary. Okay, change. No. Wheel has many kind of okay, so center axle is different, and it has tire is red, and like that. Okay, we'll add various things. So if I move this, then wheel would rotate. I believe wheel rotated. Okay, so rotation stuff we have put in the wheel class itself, and there it receives the event, and then it does the transformation locally for the wheel. Okay, now we can add more things. Okay, so probably we can copy paste and we can add. It's not a good way to copy paste. We can type in. Okay, when it is in my hand, I can give various colors. Okay, now car is really a different kind of car. Okay, so where now we can see the axle. Means it is really this side, that side, all are nicely fitted. It's really a car. All wheels are rotating. Okay, so I think we are done. If a road is like this. Okay, so we can kind of zoom in. Any part we can show nicely. So this is grand coordinate kind of rotation. So we can really see the car the way we want. Okay, so Mr. Car is again back, and then it is ready to move. Okay, so it went. Now we can add more car. Okay, so I can add like this. We have 5, I believe. 5YY. Okay. Same object is loco 2, And here, okay, I would rather say, I believe, okay, this is angle, to translate would kind of precede the angle. So I would rather say kind of go to 4, -4 or -3, -4 will try, and 0 and 0. So we are kind of locating the car, where car would go. Okay, and here I can just say that go to kind of 4, 0 and 0. Okay, so we have added to our shader model. People call it scenery also, but it is far kind of advanced. And this is kind of, we have added 3 shaders to each shader we have added. Now, can we see the classic? We have only 2 objects, loco and wheel, and then we are making so many. Okay, so that pressure would not be on the shaders. Oh, we have 3 cars, and if I can move one, okay, wheels are rotating for everyone, so that will take care. Okay, so it would rotate, and it is ready to go. What about next car? Okay, this is software. Okay, what about this car? So this car ready to turn. Okay, we have not forgotten our old car. So no one can stop us, this car, to come back. I believe it will collide. So it can come smoothly. Okay, I'll try changing the color of wheels if it is possible right now. So I'll make it opposite. So now it is red. So this one I'll make it kind of red, yellow, yellow and red. Let's see if it is like that. It works. Red, yellow, yellow and red. Okay, so probably this need to be taken care. Okay, so this much it does. So we tried adding loco and then material diffuse to different color. So if I set this to blue, yellow, blue, yellow. Okay, so right now it's not possible. So this much is developed, okay, locally. Okay, good thing is we can rotate the way we want in global axis also. Okay, so I think it's enough. I think we have really tilted it. Okay, I believe it's okay. Okay, so this car gone. Okay, so this is kind of a multi-texturing where we have a wheel and car separately, and then they are moving. Okay. Okay, so we'll proceed on multi-texture. So we showed architecture of this. So we'll add slides. Okay, so we'll see the like shader primarily are texture shaders and color shader. Okay, they means shader can be many, but primarily they are of these types, and there can be n number of shaders. Okay, so how shader and our object what we draw are interrelated, that we'll see, and each shader can have kind of static uniforms. A shader can have uniforms and a shader can have attributes. Both are kind of attributes are like vertices property. Other than vertices property are uniforms like material color and text and lighting and uh, any other, like whatever we feel that we did not call per vertex for a kind of uh, for a set of vertices, that is called VAO, or for a particular VAO it would be constant, so that we place in uniforms. So we can have multiple shaders. How? Okay, so this is kind of static uniform and static attributes. So if I go for a shader which has uniform, it has a static set of uniforms and a static set of attributes, then there can be too many shaders. But good thing is that we do not change anything, so we can just create kind of for one specific thing one particular shader. Or we can have dynamic uniforms. So these uniforms would change, okay, but attributes are still static. And so now if you go for dynamic uniform, then we don't need multiple textures. Only two texture would work. One is color texture and one color shader and one texture shader, where uniforms will change as we need. So this is the architecture. Now if I need to draw an object, okay, so object can have many VAO. VAO is nothing but a kind of it is set of vertices with a different kind of properties. Okay, like one VAO is we can say it's a color VAO. One VAO is a texture VAO. like if I have an object, some part we are coloring through texture, some part we are coloring through color, then each will carry different VO. If they are different VO, each VO can have a set of uniforms. So this VO, okay, these are VO. So this VO has a uniform. This VO has another set of uniform. And each VO will be contained in a shader. So object is nothing but set of VOs. And each VO can have separate uniform. And then finally VO get stored in shaders. Okay, so this is the architecture. Okay, so in live session we will show kind of more things. Okay, so we'll see kind of more advanced version. Now we can see that all the cars have different color wheels and they would so we are going with this architecture. Okay, so static attributes and dynamic uniforms, so that we need only one texture, a shader and one color shade. Now for every object we identify the VOs. It is either a texture VO or color VO, and they would go in their shader appropriately. They contain set of uniform, so that would keep changing. Okay, so we are here. So I'll copy shader.py, that is kind of core stuff, and I shall copy wheel.py. So this we have changed. Okay, now when we are pushing, so 3 we are pushing. So object, when we push, we kind of place the index. This object has which parent, and this object has which parent. So now 0 everywhere means the root parent, and accordingly wheel will set. So wheel 2 parent is 0. Okay, now here parent is 1, and okay, what is 1, 2? First we have kind of loco. Loco is the jeep or car, and it has parent as 0. Everywhere 0 means they belongs to topmost object, and this its wheel has parent of 0, means this loco, first loco is a kind of it will have index as 0. Okay, second loco index as 1, and third as index of or identity as 2. So these wheels, they belong to all zeros, and these 1, and so we are differentiating wheels in this fashion. Okay, this is the first thing. Second thing is, if we see wheel.mtl, as we said, now we can see there are 2 MTLs. So we can say that there will be 2 VAO. Now for this VAO, probably in future we'll change it to material, but right now material ID. So if this is the color, then we will have different kind of coloring. Okay, so now material diffuse will change. and we'll say like then add a kind of red. Okay, so now we will, if VAO has this color attribute, then please modify it to kind of a green. So okay, now we are looking for yellow. So we'll say modify it to 1. Okay, so what was it? So, or we'll say modify it to blue. Okay, so modify it to green. Okay, similarly we'll change this. So now we can have all the wheels with different colors. So we'll make it yellow and green only. So it is yellow and yellow or red. Yellow and red. Okay, and now we have third jeep. So it will be kind of blue and yellow. Okay, so blue and yellow. Okay, so we are done. Means now we have set all the wheels attribute, and we'll see what extra it does. So we'll execute. I hope it should work. Okay, so now we'll add here in display which one is active. Key press active equal to count. I hope it doesn't want more than this. So which one is active? Oh, okay, so finally we have all three cars with different kind of wheels, and now I can move a car. Its wheel is rotating, whereas other car's wheel is not rotating. This was the defect. We can see the tire is rotating. Now it has made angle. So it is really moving left and right. Okay, so we can see tire is rotating. I have made up to 20 only, so that we can change. Okay, so we have made that it will not rotate more than 30, 20. So probably we will change it to 30. And if okay, so the wheel is rotating. We can see it is making angle. Okay, so wheel has rotated. Now it is straight now and it is moving. Okay, so wheel, can we see that wheel is at it is really, wheel is rotating. Okay, not only kind of when it moves, but when it makes angle, see, so nicely wheel is rotating. Now wheel is, someone should say that it rotated. Okay. See, wheels means the wheel is like it is really kind of see. Okay, so wheel is appropriately, it is rotating. And while moving straight, it is, see. Amazing. Okay, and so good thing is that in texture mode we did not change much. Okay, so while moving back, it is not resetting the wheel. Okay, so this is how it is. So we can kind of bring things okay, so wheels are rotating appropriately. Okay, so we have now, we are in kind of multi shaders. So in multi shader, we are really using multi shader. And now, so this is for now, and then we'll see how we can kind of make it more complex, more interesting. Okay, so in multi-shaders, we have reached to a state. Generally, people they for each model, people carry one shader, and whenever they want to schedule the model, schedule the a particular model on the processor. I mean, generally people schedule the subroutine on the processor. But when we schedule in OpenGL, when we schedule the particular model in the OpenGL system, that is the processor, for processing it. Okay, so miss that is a multi-shader. Means we have kind of multiple shader, one shader for each model, and with GL use program, that model is getting scheduled to the OpenGL system. Okay, so that is the typical scenario. Now, with each shader is kind of, we consider it as a GPU. Now, with each shader, we have memory attached to it, and generally we kind of tend to provide two kind of memory. Means since it is GPU, and we are feeding from the outside data into the GPU for fast calculation, and taking out the data from the GTU calculated one. So there are two ways we can push in the data. One is through uniform variable, and another is through attributes. So attributes are vertex attribute like vertex position, and then normal and texture coordinate or colors. Okay. Otherwise, uniforms we push in. So attributes since it is vertex attribute, so in a model there can be thousands of vertices. So vertex shader get called if it has 10,000 vertices, 10,000 times to make one kind of transformation. So there are many variables. So 10,000 times they get called, and each time the vertex attribute, new vertex attribute goes to the shader, like vertices and its attribute. But there are for each model, okay, later we will see that model is nothing but set of VOs. So, but anyway, for each model, when a vertex shader is getting called 10,000 times for one transformation, but there are variables, they don't need to be changed during 10,000 calls. So we specify it as kind of uniform variable. That is the provision that has been provided. Uniform variable. Now, uniform variable. So if I like a uniform variable like projection matrix, model matrix, view matrix, transpose inverse of the model view matrix. So these are kind of these are kind of ignited. Okay. So first you push in, so you ignite it, and then keep pushing the vertices. And once you done with that, then it will do some computation and it will call fragment shader, and then it will get your color buffer and depth buffer and stencil buffer modification is done. Keep doing that. So that is kind of ignited through GL vertex array calls like GL draw element, or I think draw arrays. So with those kind of calls. So when we want more, okay, so like in any personal life also. So if we want to achieve more, means frequency is high. Frequency is high because in that duration only you have to do more, because there is only 24 hours in everyone's life. So if someone wants to achieve more, okay, then he has to increase the frequency. If someone is going to achieve more, then design should be simpler to simple. So if I want to, now we have seen transformations in multi-shader. Like there are three cars and they are moving in kind of haphazard here and there. Okay, and we can see that not only car, their local code, their local items like wheels, they also get transformation. First thing is they get moved through the way car is moving, and then internal transformation, separate transformation. They are also doing. That is important. Like if I am moving, my hand cannot move with me silently. It may do like this or like this. Okay. So even though I am moving, but my hands, that is local to my body, it has some additional movement. So that is required. So that everything we have seen now. So what is that is missing is light calculation. Without light calculation, there is no lighting in life. So without light means without sun means everything is gone. If someone just thinks that next 7 days there won't be any sun at all, means it will be completely dark, and there is no guarantee that after 7 days sun would appear or not. So means it will be a kind of catastrophe, and that catastrophe may happen in few hours only. 7 days is not required. Okay, so light without life is no life. So now light calculation that we will see. So as we are talking that when we proceed with a higher complexity, design should be simpler. So anyway, we have made our design simple. Now we have texture shader and color shader separately. So we have come to two pair of shaders, vertex and fragment for the texture and for the color. Now we are merging those. So there is only one shader now, one vertex and one fragmentation. And then for kind of texturing, that we are using the same vertex, and for the color we are going to use same. So that is required, because if I am doing light computation, just think about light computation. A light can be positional, or a light can be directional. Like light coming from sun is directional. It doesn't matter where I move, means shadow will be in same direction. And so means sun is not going to move. So that is directional light, or if it is a positional light like bulb light or lantern light or candle light, so we can move the candle and means computation would change. So first of all, light is of two types. Now light is of two types. Light itself has characteristics that light can be kind of it can be, if it is positional, then first of all it would move the way we said. Then it may be kind of a spotlight. If it is a spotlight, then a spot direction is another complexity. If spot direction is another complexity, then kind of spotlight exponent, that how it will kind of it will kind of the light would scatter. So that computation. This is apart from ambient, diffuse, and specular and shining computation. Now, once we are done with these many calculations, now there can be multiple lights. Okay. Now, one object is drawing its color. He has to think about ambient, diffuse, and specular, and then he has to think about light from so many directions. Okay, that much computation. Now, if I am at par with all these calculations, light can be stationary or light can be moving, like a car headlight. If it is moving, then computation would change. Okay, and that so this much, this much I am talking minimum. There can be more. If I have heavy weight drawings and one car is moving on road, and it has light. So it has a spotlight, and probably road it will the illumination would change, or tree illumination would change. Otherwise, nothing else would change. No need to redraw everything. Okay, so we can have multiple color buffer attached to one frame buffer, one frame buffer object. So frame buffer object it doesn't have any buffer, so it is kind of it composes a light buffer, it composes a kind of color buffer, depth buffer, stencil buffer. So we can kind of we can make the light computation in passes. In one pass, whatever is calculated, that will go to one color buffer. Next pass, then next pass, whatever is changed, then we have to merge it, and that will finally will fed to the kind of a display buffer that we see on the monitor. So that much complex is there, then we get light in our life. Okay, so this is screen computation, what we are doing mathematics. Just think about how sunlight is coming and how much means if I see our eye as computation or our brain, just think how much computation it is doing and how much God has granted to us. Means we just think in a physics way that it falls and a lens is taking, it's not that simple. Because if you go inside the eye, then finally it converts into electromagnetic signal and that goes to brain. So it's not optical light what I am receiving, and there is a lens, and then after the lens it is falling to the kind of, so all the organs what we see, they are kind of we can say external electronic devices, and they are connected to kind of brain through wire, and these are kind of transducers, and whatever they will be, if through eye we see so much light calculation, then all those finally at the end, whatever we will do, that signal will pass to the kind of OpenGL brain, and then it will display. So that signal is passed to our brain. So marvelous. Means whatever we are doing, that is nothing in comparison of what we actually it's being done. Anyway, so now we will proceed towards the light computation that we will see. Okay, so now we had kind of we saw that we have one color and one texture shader. Now, as per the discussion, now we'll move into kind of lighting calculation. So when we move into lighting calculation, so things are pretty complex, and we can't afford kind of dual. So idea is that we'll kind of merge. So we will remove this, and to have only one color and texture. Okay, so now only one color and texture. So this is what is the idea, and okay, so texture shader, color shader, so they are merged. Okay, so idea is that we have to merge, so we merged. Now So we had like this. So now one is gone, only one remains. Okay, and okay, so in shaders there is kind of only one shader. Okay, textures, so I can say it like texture come color shader. Okay, so this is the new idea. Where are we? Okay, so we can kind of include this. Okay, so kind of this is the new design. Now uniform will remain kind of writable, and we have a static, and now shader is only one. So from both angle we are showing shader is only one, and here also shader is only one. So that is the idea. Now we can proceed with the light calculation. So what is light calculation we are talking about? Okay, so in texturing, in shaders texturing, we have already seen light calculation. So this is light calculation. Okay, so if I consider this as surface, okay, so this is the surface, what we see as a kind of a paralleloid or ellipsoid, and this white one, this is light source, and I need to draw various kind of vertices. This is one of them, and it is one of them. What is the situation now? If light is here and it is a positional light, then light falls on this vertex. If it falls on this vertex, then whatever line we are seeing, this line is kind of L means light, is a light vector, and what we see yellow color, this is normal vector of that point. So whatever angle is between light vector and normal vector, L dot n, so that much light effect will reduce. So L dot n means if I do kind of cos theta, if it is 0, then maximum light would fall, and whatever is theta now, so that much light will be less here. Light would be maximum here, as it is kind of angle is 0. If angle is 0, then light would fall directly upon it. If I see this diagram, and if vertex is here, if vertex is here, okay, so light would fall directly on it, whereas the normal of this is also on the same line. So angle is 0. If that is the case, then illumination would be maximum. So this is for kind of diffusive illumination. Specular is shininess. Where our eye is, generally we keep our eye at fixed coordinate 0, 0, 0. So this line is I vector, okay, and this is normal vector. So we take the reflection of the light. So this is the light. If I reflect this light, okay, then it would be like this. Okay, so light would reflect like this. This yellow is normal vector. So if I reflect light on normal vector, it will become like this. Then we calculate the angle between this line, that is the reflection, and from the eye, this line. And if it is more than 90 degrees, then there is no shining. So that is the calculation. Now suppose we talked about if vertex is here. If vertex is here, then L, that is light component, light vector is like this, and normal is anyway like this, then cos theta will be cos theta of this angle, so it will be around nothing. So this guy won't receive light or very minimal. Okay, now we have to kind of, if I see the specular component, we saw the diffuse specular component, then I have to draw I. So I would be like this. So I have to draw I like this. So I will be like this. And then I have to draw reflection from here. So reflection would be like this. So this is obtuse angle. Now the angle between what we draw, so this angle between this and this is more than 90 degrees, so it won't get any shining at all. Okay, so that is the science. Okay, anyways, so probably we can include this side here only. So I can say it as save as and save in the probably we are in multi-shader. So here we'll save as multi-shader and we'll give name as kind of 3.34. Okay, so we can include here itself. This is what it is. Okay, it came. Okay, so lighting calculation we saw. Now we'll see in the lab. So what we have in the lab section. So in lab section we will kind of we'll have different kind of thing. So that will be like okay. So in lab session we will have kind of okay. So solar system. So this is sun. It looks like sun, and this is far, far away. This is Earth, and it is its natural satellite. Okay. So now we can see that how much it is glowing, and Earth is glowing in the direction of sun, and then the moon. Means it happens this way only in real life also. Okay. So now we'll do the lighting. So we'll kind of modify this. So we have utili shader.utili, shader I none, key press none whatsoever. Now, so we will stop this loco for right now, and so we'll comment it. So loco we don't need, and here okay, so everything is same. We'll add one guy called Earth. Okay, so we'll have Earth, and now we can add Earth here. So we'll give name as Earth 2, and it is the Earth, and which is a shader of file equal to sphere.opt. OpenGL characteristics is material.diffuse. This is yellow world map.png. Okay, and now we have to put what is the kind of VAO in the material file. So we say unknown. Why will say unknown? Okay, so and then we'll put other characteristics like light.diffuse. We'll put to fixed transformation. So where it would lie. So we'll make it kind of 6. How big it would be? 0.2. It is very small. Means it is 100 times smaller than sun. Actually, Earth is 100 times smaller than sun. If we see one dimension, single dimension. Okay, so now why we are giving unknown? What is that? So if I see kind of no sphere, okay, so if I see face, use metal is none. So it is not using any material, but it has texture coordinates. We can see this. So if it is like this, then we say okay, so material diffuse is, this is the image, but we don't know it's a material component, so we just say unknown. And light diffuse is 2. Okay, so now we will append children to it. Okay, so things are changing. Earth2.children dot append, and here I'll append a moon. So moon is simple, a shader, object file is sphere. OpenGL material diffuse is moon.jpg, moon.png. Again it is unknown because it is using same shader. And light.diffuse, we are using same. Now it will have some specular component because it really shines the way we see in the sky. So specular component it will have. So that is kind of 0.2, 0.2, 0.2. We will just fill whatever the characteristics we want. Material dot specular. Okay, so that will fill as 1.1. Okay, so okay, now we'll add a kind of a fixed transformation. So fixed transformation is in x direction it is 3 and 0, and it is scaled by same. So okay, and we have shader out file this, OpenGL component is this, fixed transformation equal to 300s. Okay, now we can add this. So I'll say shader I. So that is the topmost shader. Okay, so global shader I and shader I equal to out file equal to none, that we have set. Now that is the topmost model we can say. So shader I dot children dot append earth2. Okay, like this we'll have a kind of sun. It is pretty simple. Means now I can say shader I dot children append a shader object sphere OpenGL. Okay, so it is now sun.png. Okay, what is characteristics of Mr. Sun? Okay, so we are keeping the light component. If I see this lab, the light component is inside the sun. If light is inside the sun, there won't be any sun, Anyway, we'll see that scenario also. So I will say we don't want anything. Okay, nothing. Okay, so it's done. Now we have kind of earth and like this. Okay, so we can start. Now in display we have, so here we can make 20, and in display we will have something little different. Okay, so I can say kind of active equal to false at the beginning. Okay, so false. And now in the keyboard, so we have pushed the keyboard kind of to, okay, so we don't need now. So keyboard is pushed in the model only. So life is easy. I can just say glut post redisplay if shader dot. So now what shader is in focus? So focus object root shader I key equal to whatever key we are receiving, x equal to x. Okay, I think it's okay. Anyway we are not using this x and y. Okay, else none. Okay, so focus shader object. So what we are doing behind the scene is that we update only when the keyboard returns true. Means if something has happened in the keyboard, then otherwise there are special keys that I keep pressing to do some extra work. For that we don't need any post redisplay, otherwise we'll do. That's it. Can someone believe that this minor change will bring a solar system? So we added Earth and Earth children, then we appended Earth, and then in shader I we appended Mr. Sun. Okay, so we'll copy shader.py here and we'll copy, I believe Sun is not there, we'll copy Sun, we'll copy Moon, we'll copy yellow map.png here, we'll copy Earth, okay, so many things we have now here, and we have copied sphere.obj, material file is not there anyway. Okay, so we are ready to go. Okay, so we have done something wrong. We have not closed it. Okay, so here we have closed it and fixed transformation. Probably we are using two curly braces. One is this OpenGL. Okay, and we are okay, so fixed transformation is probably extra component. We'll try, but there is no harm in trying. Okay, so column expected to fixed transformation equal to. Okay, so what is the problem? Okay, I don't think that is a dictionary, so we'll change it again. 42. This is dictionary. Okay, and fixed transformation is this, and that is the Earth. I believe it should be all right. We'll try again. Okay, so there is no file called untitled.mtl. It is trying to read. Is there? Okay, we'll copy. What is there in untitled? Okay, something is there. So many. Okay, anyway, but we are not using it. So we'll try again. Okay, we are not getting anything. Oh, it's there. Okay, so we can see, I believe we have done too much. So we will change it. And we'll make it 600. Otherwise, it is taking a corner. Okay. And here, I believe it should be alright. We are using 30. We try. Okay. It is again going for. Okay. So we'll make it angle little more. GLU perspective. Kind of 40. Okay. So Earth is appearing. If someone can see Earth and Moon, but there is no Sun, as our light source is at the origin, and Sun is drawn at the origin, and it is a positional light source. If this is a positional light source, Sun would not appear. So one solution is we'll change. So in shader.py we have kind of default. So this is positional light. I'll make it as a kind of directional light where it is coming from positive Z direction light. Oh, we can see the Sun and Earth and its Moon. Okay, but light is coming from kind of a positive Z direction. So Sun is glowing from some other light. That is the problem. Okay, so that side of the Sun there is no light. So if I rotate complete global axis, okay, so global axis is not rotating. Okay, so we have to modify again. Okay, so key equal to key. Okay, so we make it as string encode. So, encode or decode? Encode, decode. If I decode, then it should become kind of a string. This is what we want. Okay, so if I rotate the global axis, so other side of Sun is, there is no light. And then, so light is in one direction only. This is what the problem is. Okay. Others, full we are rotating. Other side of Sun, there is no light. So this is not the what anyone would like to have, that Sun is glowing from some other side. Okay. So I believe I can. So that is the issue. So what we'll do, we will change the kind of its position. So now it is a positional light. And whatever the characteristics we filled for the Sun, here we'll add more. Okay. So ambience calculation uses texture. So in ambience calculation, so we'll force ambient calculation. So I'll say material dot ambience is kind of it is big 3 3 3 3 3 and okay, light dot ambience again as kind of 1. Okay, so this much we will set. So this is something nonsense we are doing because we want sun to glow and light is inside that. Okay, so that way sun will never glow. So we are using material ambience and light ambience. It would be ambient. Okay, so now it should glow. Sun is glowing. And far, far in the universe, the earth is located. We can see earth. Now, okay, so this is Mr. Sun. Sunlight is falling on earth and moon. We can bring more near. Okay. Now, moon rotates around earth. Can we see? What about this? Okay. When moon is in front of earth and sun not directly, this is condition of a night when there is no moon. Okay. So, if I further rotate the moon, I believe it should be visible. And it goes behind. Okay. If it goes behind, okay, and somehow it glows, it is at a position where here it is getting complete light from the sun. And person who is standing on the earth in night, he is seeing the full moon. This is condition of full moon. Okay. Now, moon would be half moon and it is full, no moon night, moonless night. And then, okay, one by one day starts and then it is full moon. Then, okay, earth rotates on its own axis. That is also the case. So, I can say like, okay, earth also rotates on its own axis. Okay, and earth rotates on around the sun also. Taking the moon together. Okay, so okay, so earth rotates around the sun. Okay, so this is night life on other side of the earth. Okay, we can zoom the earth now. So this is kind of deep in space. And earth rotates on its own axis. Whereas Mr. Moon is on that side. This is Pacific Ocean, I believe. So this is no moon night, half moon, full moon night, and again half moon, but other side means at noon in night the kind of would appear. Now earth is rotating, taking the moon. Wow. Okay, so in next session we'll have more complex lighting. Okay, so more complex lighting in the sense that we'll have spotlights and then we'll see that, and we'll have multiple lights, we'll have moving lights, we have all possible combination of lighting that we'll see. Okay, so we'll proceed on multi-lighting setting. So what we showed, so now we have only one light source. This is what we are saying. Now light source will be many. Okay, so it will be like this. Okay, so right now in multi-shader, so we saw one light, now we will have many lights here and there, and light may be moving. Okay, so that is the scenario in the multi-shader light. Now from everywhere what we will have is kind of, this is light coordinate, this is light, so what extra we get, so this is light extra we get, otherwise E is same, and then direction we will get differently, so everywhere the direction would be different. So if I consider this as direction, then direction of light would be somewhere here, somewhere here, this somewhere here, this somewhere here, and this is L, light directions, and this is, so this is called a spotlight direction. So spotlight direction would change. So calculation is pretty complex in multi-light scenario. So these are called D, that is the directional light, that is a spotlight. So this is one thing, multi-light scenario. In another scenario, the light direction would move, light position would move. So here it is now, it may go here, and what we see the kind of its spot angle, a spot direction. So spot direction would change if I move the light, okay, to somewhere. So multi-light scenario is difficult and light type may be different. So this light can be kind of directional light, whereas this light is also a directional light, whereas these are positional light. So this is too complex, and now light would change in its direction, okay. So this we say kind of multi-lighting scenario. Okay, so this is multi-lighting scenario. Okay, so life is not easy. So what we do is, so when we go for multi-lighting scenario in that way, so if I see the kind of whatever we are using shader file, so shader file would change now. So I'll copy the shader file now what we are using. Okay, so in shader file, so this is the light computation we are using for the shader file, attenuation and everything. So we are using for the attenuation, okay, so distance square. And if I see other stuff, then we are using kind of for the light source, okay, so light position would move if I move the light. If light position is moving, then we will move the kind of so we will set a light position accordingly, and we will change the spotlight spot direction. So we can see clearly spot direction will change to the light, and whatever spot direction we get, that is transpose and inverse, and we do transpose extra because OpenGL does the transpose, so we again transpose it. And then, so in lighting calculation, we have light, maximum light 4 we have set, and now it is an array now. So light is an array, and if light is an array, then for each light, now we do the calculation, this much hectic, and then we do the computation. Okay, so we'll change the source code what we have written. Okay, so from shader, okay, so from loco we will import loco, and wheel is not required because wheel we have placed inside the loco, and earth is not required. Util I is shader util I. Okay, shader I none, key press and count we have removed, so not required. Okay, so we have written hectic code. So probably I can, it is anyway cleaned. Okay, so I would really make it really very small. Okay. So now here in the translation we translate to kind of 15, and Okay, so code is modified and life is pretty easy. Okay, so this is a kind of a simple code, and really perspective we can use 40 and it is kind of some 70 we can use. Okay, and 15 but that's it. This is the code. Now we will add like shader I osh file equal to none. So we will add locomotive. So loco 2 equal to loco, and we will set transformation. Okay, so initially we will push it to kind of -40 location, so that the vehicle should look transformation kind of it is far. Okay, so we transform it, okay, along y-axis, because the car is along the x-axis, so we make it along the z-axis, so we transform it along the y-axis. Okay, now we'll add children to it. So we have tree, so for lighting purpose, so I'll say dot children dot append, or probably I can show this much only. Okay, so I'll add a kind of a global light source. Okay, so shader I dot children dot append. Now things are pretty simple. Shader of file equal to none. So I'm adding a light source. Light position is okay. So this is a directional light, and light diffuse is so one light we have added so that there should be some ambience. Okay, so and loco inside that it has its light, and now we will modify. So we'll append loco. So shader I dot children dot append, okay, and then we'll append the loco 2. So loco is the kind of car taxi, and that we have created, and so that's it. And in display, so we'll show the loco file, and here we do active pulse. Then in the keyboard, so keyboard is only one line code now. If shader I dot keyboard key equal to key, x equal to x, y equal to y, else none. Okay, so glut post redisplay if shader I keyboard, that's it. So the code is reduced to this much. So nothing is required, everything is handled by the framework. Okay, and we have added already. Okay, so I'll show the loco file. So loco file I'll copy. Okay, so loco file is nothing but it will add wheels, and then it will add 2 lights, headlight, and it will add kind of one light source. It should add 2 light source actually, but right now we are adding only one light source. Okay, probably during the discussion we can change it. Okay, so that is the scenario. We have kept position as this is a positional light source. Diffuse high we have made so that it will be prominent, and a spot angle it is not required, but we have used attenuation is kind of if I see the attenuation, then we have used a square. So for a square we need the angle, otherwise 30-40 angle is also enough. Okay, so I'll copy the wheel. Okay, so I can try. I don't think we need any. We are using other OPS file, wheel.mtl and car2.mtl, so that we'll copy. Car2.mtl we can leave it and we'll try. But okay, so we'll try using the original shader, what is the framework. So we'll import sys.part.append. Okay, so we'll try again. Expand user. Okay, so it is better. Okay, so we can see a car with a headlight. So it is like okay, so car is not making any rotation. Okay, so we have to use keyboard too. So that is the new architecture. We'll try again. Okay, so car is appearing to move, and this is dark night, and there are two lights. If we see, one is car headlight and one is the global light through which we are seeing the car. Now we can see the car. Okay, so as if car is kind of moving in a dark night. So that is a scenario. So these are lighting calculations. Now we will add few things so that it will be more prominent. So I'll append kind of a tree we have. Okay, so I have a tree, so that we are going to append. So I'll say children dot append shader of file equal to, okay, so I'll say tree dot obj, and then we'll add other stuff like fixed transformation where tree would go. So I can start with kind of -600 and material dot diffuse. Okay, so how it would look? So it would look green, the leaf. Otherwise, default is color is not very good. So probably I'll copy it. Okay, I can just copy it, and material file also I'll copy it. If I open the material file, okay, so leaf stuff will make it kind of a little brighter. Okay, or if we want to use the same leaf, then we have to use, we'll try using same leaf color, but then, okay, now we are adding fixed transformation and we won't add anything. Okay, so that is it. Opt file is burst tree dot opt. So we'll see now if any tree is appearing. Oh, there is a tree, means it is not aligned. -600, I think it's okay. Okay, so I can see I don't think tree is very kind of, okay, and unfortunately tree is also moving. This is certainly we don't want. Tree should be at same location. Okay, so we will add it as shader I children, not car children. Okay, so tree, can someone see the tree? Tree is not visible. Okay, so we'll make tree kind of smaller, and then we'll add more trees. So tree is here, but it is not visible. Okay, so -600. We'll do some scaling. Okay, so in fixed transformation, we'll do some scaling, kind of 0.5, 0.5, 0.5. Then we'll see if we are able to make it. Okay, so if I bring the car near, okay, so tree is visible. So this is the tree. Okay, now it is kind of far away from the car. This is the tree. Okay, so this is a thriller movie. Like in night, someone is driving the car. This is it. Okay, so we have used a kind of lot of attenuation. That's why it is not very much visible. So we'll see reducing it, but we'll add trees. So in lab session, we will have another. So this will kind of reach something like this. Okay, so it will become like this. We have lot of trees are there and car is moving. So we'll add other trees. Okay, so 6 trees we are adding. Where we'll add, so that we'll see, we'll add other side and it can be like minus 10 and this side at 10 and we'll make it kind of this as 3 and okay 6 is okay, so 3 and then 3 minus 10 kind of minus 15 minus 15, so both side of the road we will decorate with a tree. That is the idea. Okay, so it will be kind of 3 and then one tree will be far, so we'll make it kind of 2 and it will be kind of minus 20. So 6 trees we have added. Okay, minus 6 at 0, 6 at minus 10 and like this. Let's see. Okay, probably attenuation factor is too high, but we'll try running the car. Okay, so car is running and we can see the tree. We'll change the tree colors. Okay, probably default color is too low. That's why the idea was to change the color. So I can say now material diffuse equal to externally we are pushing whatever is provided by default kind of 0 to 0 tree dot birch dot leaf. So we are overriding this. Material file, we are overriding this. So probably we can copy paste. Okay, so diffuse we have set now. So material diffuse is, this is what we want. So we will set it for others, material diffuse. We'll see if it really executes, then only we'll set. Okay, so one, this is prominent that we can see. So we'll set for others. Okay, and we'll make it kind of yellow, and we can make it kind of very big, means it should be highly prominent. Okay, so we'll make it kind of okay, so this will make it okay, so no one stops us giving the colors what we want, and then we'll make it kind of a real green. Okay, this is the last one, so we'll make it kind of 6. Okay, so we'll try now. Material diffuse equal to does not match the opening braces. 26. Okay, so this is fixed transformation. So it went there somehow. Okay, this is far better. Okay, so now we can see that car light has an effect, and the tree colors are growing. Okay, so that much we are getting kind of by default by the other color. So we'll reduce it, means it is too high. So we'll say like it is 2 and 2, it is 2 and 2, it is 2 and 1 and 1, it is 2, it is 2 and 2. We'll try again. Okay, so this is how it is. So now I can kind of rotate it. So full angle we are rotating. Now we can see that car is moving. So big. Now we'll move the car. Now as it is approaching the tree, the light on the tree will be brighter. And if tree is passing, then after that the light will be gone. So this is what is the lighting. Okay, so now it is passing the last tree. Light is gone on the tree. Okay, I can rotate the car. The way it is rotating, it will illuminating other trees. Okay, so if I rotate the Now the way car is rotating and it is illuminating the trees. This is lighting. Now if car moves near to the tree, then light will be brighter. If it moves far away from the tree, the light will be less. Okay, as per the light calculation. So now we can see this, the light has gone. Others also it will be faded slowly. It faded because car is away. If car comes, it will be brighter. Now we can see the trees are brighter. Car passed. Okay, so this is a kind of moving light and multi-source light. I think few trees we can make height as one, so we have reduced too much. So we won't scale few trees. Okay, that is at least which is the near one. Okay, we can add one more tree kind of at the near only. So on the other side, probably at 4, we'll add one more tree, and this will look kind of more like red. Okay, so now we have one more tree on this side, and if I move the car, then trees are glowing. If car is passing the tree, then so this is a spotlight. Can we see? Means it's not omni. So car passed. Now I can rotate the car, and it is illuminating the trees the way it is focusing. Okay, if I manage to, then full tree will be illuminated. Now car is going back. Okay, so this is a kind of a lighting model. We can try again. And we can kind of bring it near so that we can really see it. Now full scene I am bringing kind of near. Now we can see. The way car is approaching near, the trees are brighter. And when car is passing, then trees are completely dark. Okay, so in global form also we can see. Where we are. Okay, so car is passing like this. Now car is passing the trees. And car passed. So this is we are using everything, attenuation and everything. I can kind of reverse the car. Okay, so I can change kind of so we have used like attenuation, clamp. So I can kind of comment it. This is crucial file, and I have used that. So I can use linear also. There is nothing like that. Okay, I can place it some multiple like 4 and then completely linear. Okay, it is brighter. Okay, someone can say this is good. It will be more brighter if it approaches near. Okay, so angle is too much. What we are using for the loco, so it is we are using kind of spot angle 80 degree, not required this much, so we can make it like 40 degree. So once kind of once car passes, then it will be more realistic with less angle. Okay, now we can see. Okay, I can rotate the car. There is no light because we understand, so I have to move the car behind to get it lighted. Now if I move the car, okay, so this is lighting, multi-source lighting. We'll see more. Okay, so we will add more examples to it. So in multi-shader, we saw only one. Now we'll add more. Okay, so we'll see what we have done. We can copy again few files. Okay, so it's all right. Now, okay, so we have kind of a car. So we'll add few things like material dot diffuse. So material dot diffuse would be taken care, I believe. So I think it's okay. We'll try once, then we'll add few more things. And what about the lighting we have placed externally? Okay, so this lighting diffuse is 0.2. We'll add a specular. Okay, not bad. Okay, so not bad. So we'll add more to it. So we have one loco, and we will kind of start at some 6 and minus 10, and then we will have another loco that will start at minus 6, same at minus 10, and it will be loco 3. Okay, now it is multi lighting and a multi shader. So we have two cars. So lighting, I think a little bit we can increase default lighting what we are seeing, so that someone can look at it. So light position is okay. We'll make it kind of 3. Okay, probably it is more visible. And now we have 2 cabs and they have lighting. Now if I rotate the cab, 3 lightings are changing accordingly, and I'll rotate the another cab also. So this is the light we are receiving through default. We have one default light source, and through that we are receiving. So if I rotate this, it will place light on another car. Okay, so okay, it will put light on this car. If I rotate, then it will push light here. Okay, we can see that the wheels should rotate. That is the idea. So clearly wheels are rotating as per okay, so if I again wheels completely rotated. Okay, so both cars are moving. Okay, so this is multi-lighting and multi-shader. So we have two items and now they are kind of okay, so we can simulate like on a road they are moving like this. Wheels are rotating. Okay, so now we can add kind of more to it. So whatever we have now is, so we'll make it kind of some 7. So it will be really far. And I have one aeroplane. Okay, so that I shall add. So I'll name it as loco 3. And here it will be shader and ob file equal to plane air dot. This is the name of the object file. Okay, and it would be transformed at center only and kind of some 4. Okay, so no fixed transformation we are giving. So that much. Now we can add kind of it's a specular component. So material dot specular equal to some 0.3 so it will shine in red if it shines. Okay, and material dot diffuse, that anyway it will be whatever it is, or we can. Okay, so it takes from texture.png. If it is not there, then it will crib. Okay, so we'll name it as loco 4 or air 2, and we'll add air 2 here. We'll copy plane air dot ob here and plane air material here. Plane air material needs texture.png, so I'm hoping that it would crib. Okay, so texture.png it is asking. Now if I open the plane air.mtl file and we see the texture.png, it looks that in taker demir. So we can kind of replace it whatever we want. So plane air, so we will kind of override it and then we'll say like material dot diffuse equal to, okay, and it will be kind of yellow color, whatever it is. Okay, so material diffuse. Okay, now air 2 is added. We'll try again. Oh, okay. So we can see that aeroplane has arrived. So I think we can increase the gap, loco 2, and we'll make it something like 9, and here also some 9. Okay, now we have aeroplane that we can see, and then we have cars. So this car I can move. Okay, and I can rotate. Okay, so Mr. Aeroplane is getting light through one of the car. Okay, reddish shining can be seen little bit. It's coming. Okay, I can make prominent, but I believe it's all right. Okay, so ready to move. So it is moving through the car light. Okay, so car light is gone, so it is not visible. So I'll bring the car light, I can kind of so that it can show. Okay, so we can add as many things what we want. So this is kind of okay. So we have not tested our this car. Okay, now I can bring back the kind of aeroplane. Okay, it would increase the lighting if I rotate this guy. I think it's visible. Now light is more on the aeroplane. And aeroplane can land safely. Okay, so that is the concept. So we'll see it's showing the kind of okay, so this car would move now. Okay, so framework is generated. So this machine is not a high power machine, it's a very low end machine. So still we are able to do this much, as we are not using kind of everything is highly kind of optimized. Okay, shining component little bit we can try more, whatever we see in the aeroplane. So we'll make it kind of 1 so that red should appear. We'll try. Okay, I believe it is more prominent red now. Red is more prominent. So we are getting kind of a shining component also, and so shining is red shining is visible. Okay, so this is how it is. So we can make it fly in our direction. So Mr. Plane would rotate now somewhere in the middle of the tree. Okay, so it should get light, so I can rotate this guy. Okay, so this is how it is getting. It is coming in car, another car's light, headlight. Okay, so there are three light source now, two car and one light source that we are not seeing, that is from kind of external light source. And because of that light source only we are getting light. Like if I rotate this car that direction, then okay, so and this car also in some weird direction, and this car also some weird direction, still we are getting some light. So that is the one light source that we have, and other two light sources are through the car headlight. Okay, so if I rotate this car headlight, so they would kind of shine each other. Okay, spot angle is also is tested. We can try spot angle. So I'll open the loco, and this is the spot angle we can make kind of, if we are testing, then we can make it is really very small, kind of 2 degree. Okay, now if I rotate this car, then it would give a spot only, okay, that we can see very. So I can little bit tilt this. I can make it near the plane. Okay, so 2 degree is, I believe it is very less, so that's why we are not able. We will try if plane can receive something. Okay, and then I can make okay, so this much only it is able to make. So I can, if I tilt this, or I can move it up, you can see this is spotlight. So this is the car light, but it is only 2 degree angle that we can see on the aeroplane. So, and there is one light in the car. So 2 lights are there only for show, but we are using only one light. So car is showing only 2 degree of the angle. So this is the spot angle, and as obvious we can increase the spot angle. Okay, so this kind of This framework is local framework. We have not copied from anywhere. Okay, now now it is bigger, so we can see. Now if I rotate the plane, we can see the lighting. Okay, so this is about multi-texturing. We are using so many textures, and multi-lighting and lighting. Now multi-light with all its, now we can see reddish shininess, we see the spot angle, and then we can see moving lights. Okay, so multiple light, moving light. The third light, what we are not able to see, that is directional light, and these are positional light from the car. Okay, so we have used less angle. So whatever the light we see in the plane, that is from the third angle. Otherwise, no one stops us to illuminate the